What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 7, Practice Test. Let's do it. So here we're converting radians to degrees, and when we do that, you take the measure in radians and you multiply by 180 over pi. Now the pi's cancel out, and you can divide 180 and 6 by 6, so that's 1 and that's 30. Last but not least, multiply those together, and we get 150 degrees. Boom, done. So this one says find the length of a circular arc with radius 12 centimeters subtended by the central angle of 30. So this would be 30 degrees. So the formula for length of a circular arc is the central angle divided by 360 times the circumference, because you're taking a piece of the circumference, right? So it's 2 pi and then the radius, which is 12. So there's your formula. So now let's simplify that. 30 over 360 simplifies to 3 over 36, simplifies to 1 over 12. And then this is times 24 pi. So let's plug it into the calculator. So here we get 6.283. So 6.283 centimeters is the answer. Boom, done. So this one we're meant to find an angle that is coterminal with 375 that is between 0 and 360. So when we're trying to find coterminal angles, what you're going to do is you're going to either add or subtract by 360 degrees. And since this is too big, right, it's beyond 360, we're going to subtract by 360. So 375 minus 360 is 15. So that's the coterminal angle in that zone, 15 degrees, boom, done. So this one says draw the angle 315. So we're going to start with our initial side there, and then we're going to do 315. So now, you know, we're going, it's positive, so we're going counterclockwise. So this would be like 45, this would be like 90, this would be like 180. This would be like 270, and then we have another 45 to go. So kind of right here in that middle, which means 315 would be this entire angle. So that's how you do it. Boom, done. So this says a carnival has a Ferris wheel with a diameter of 80 feet, and the time for the Ferris wheel to make one revolution is 75 seconds. What is the linear speed in feet per second of a point on the Ferris wheel? And then it says, what is the angular speed in radians per second? So let's first get that linear speed. So how do we get the linear speed? We're trying to get the full distance going around divided by 75, right? Because that's how long it takes to make one revolution. So how do I get that distance? Well, if the diameter is 80, that means the radius is 40. So now we have to get the circumference. That's the distance going around. And circumference is 2 times pi times radius, which is 40. And then we have to take this and divide by 75. So here we get 2 pi times 40 divided by 75 for the linear speed, which is 3.35. So we got 3.351, and that is in feet per second. Now, if we want the angular speed in radians per second, the question is, how long does it take to go all the way around in a circle? Well, in degrees, or radians in this case, sorry, it's 2 pi. Degrees would be 360. But in this case, it's just 2 pi radians. And then it's radians per second. So again, it's taking 75 seconds to go the full distance. So it'd be radians per second right here, 2 pi over 75. So that's how you do it. Boom, done. So for this one, it says find the missing sides of the triangle. Now notice this is 60 degrees, this is 90, which means this up here is 30. So guess what? It's a special right triangle. Now, I could use trigonometry to solve this, but we don't need to, because with a special right triangle, if I know that the hypotenuse is 9, the little leg opposite 30 is half of that, which is 9 over 2. And then if I know the little leg, I can get the medium leg by taking that and multiplying by rad 3. So it'd be 9 rad 3 over 2. So that means A is 9 halves, and this is B because it's opposite angle B. B is 9 rad 3 over 2. That's how you do it. Boom, done. So for this one, it says find the exact value of sine of pi 6. Now, I can use the unit circle, or I can make a triangle recognizing that pi over 6 is 30 degrees. But let's use the unit circle. So sine of pi over 6, we look for pi over 6 here. And sine is the corresponding y value of that coordinate. So the answer is 1/2, boom, done. So this says state the domain of sine and cosine. Now, here's the thing. Sine and cosine, they can take anything, right? You can take 360. You can take 40. You could take 10,000, okay? It doesn't matter. There's no limitation in terms of the inputs for sine and cosine. So that means the domain is all real numbers, or in interval notation, we could say negative infinity to infinity. So these are the ways you could write the answer for both functions. Boom, done. So if I'm trying to find the exact value of cotangent of pi over 4, first I need to remember that cotangent is going to be x over y based on the unit circle, okay? Tangent is y over x, cotangent is x over y. Now we find pi fourths, which is right here. And so it's x over y, so it's x coordinate over y coordinate. Well, those two are the same, so anything over itself is just 1. So rad 2 over 2 over rad 2 over 2 is just 1. That's how you do it. Done. So this one says use reference angles to evaluate cosecant of 7 pi fourths. So I am going to tell you what the reference angle is, but I'm going to show you how to do this without a reference angle as well. So here's 7 pi fourths, right? So the reference angle is that shortest distance up to the x-axis, which in this case, since that's 7 pi fourths, this is 8 pi fourths or 2 pi. The difference or distance is pi over 4. So what I could do is then say, what is cosecant of pi over 4? Or it's the same as saying, what is the inverse of sine pi over 4? Because cosecant is the inverse of sine. So we go to pi over 4, sine is that y value, so it's rad 2 over 2, and then the inverse of that is 2 over rad 2. Then to rationalize the denominator, we multiply by rad 2 over rad 2. We get 2 rad 2 over 2. Those cancel out, and we're left with rad 2. But now we have to recognize that we were in quadrant 4. So what's the sign of the y values in quadrant 4? Well, it's actually negative, okay? So since we're in quadrant 4 and we're taking cosecant, which is negative in quadrant 4, this answer should be actually negative. Now, if we were to not even worry about the reference angle and just go with 7 pi fourths, this becomes much easier. We go to 7 pi fourths, we take cosecant, which is the inverse of that value, so you see the negative's already in there. So it's negative 2 over rad 2, which of course evaluates down to the same answer we have here. So negative rad 2 is the answer, boom, done. So this one says cosecant of t is this. What is cosecant of negative t? So this goes down to the symmetry properties of cosecant. And cosecant, just like sine, is an odd function, meaning cosecant of negative t is equal to negative cosecant of t, okay? So if I know this, and I know cosecant of t is 0.68, cosecant of negative t is the negative of this, which is negative 0.68. So that's how you do it. Done. So this one comes down to the notion that cosine of an angle is equal to sine of the complement of that angle. But in this case, we're in radians, so we can say the complement would be sine of 90. The equivalent to 90 is pi over 2 minus x, okay? So all we have to do is basically just say that pi over 6 is x. So the angle in here is going to be pi over 2 minus pi over 6. We can make this 3 pi over 6. They have common denominators, subtract, and we get 2 pi over 6, which reduces to pi over 3. So that's your answer. Done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.